golf course designers are trying to figure out the average golfer's driving distance, and they think it's 245, and their mean value of 166 samples gave you 244. So given that you have 47.7 as the population standard deviation, and at 5% significance level, we want to test if 245 is too much or too small. Okay. All right. So they already gave you the H0 and H1. I don't like the fact that they're not direct opposites of each other, but anyways, this is telling us that we use the one-tailed test because you're trying to go for the smaller. The shaded place will be here, so it's the left tail. Okay, so this test statistics is the z-score. So you need to get z equals to the mean value of the sample minus the population mean divided by the sigma over square root of the sample size, right? In our case, this is 244 minus 245 divided by, let's see, the 47.7 divided by square root of 166. So let's plug that into the calculator. So you have parenthesis 244 minus 245, close the parenthesis, divide, and you need this parenthesis, 47.7 divided by, and then the square root of 166, and then we close the parenthesis. Let's see what we get. We get negative 2.7, negative 0.2701. So this is negative 0.2701. Okay, so that's your test statistic. Now for the p-value, what you need to do is here's the negative 0.2701, and because you're looking for the left tail, the p-value is the area of this side, which is just the normal CDF of this negative 0.2701 in this case, because the norm CDF measures the area from negative infinity to this number. You don't have to do like 1 minus anything. This is good enough. Okay, so let's try to use that. The norm CDF, second vars, normal CDF, and then we are going to put the upper as negative 0.2701, and we're going to put enter, and the value is 0.3935. Okay, so this would be 0.3935. Okay, now because this is much bigger than the significance level, which is 0.05, this fails to reject H0, and H0 will still be the prevailing conclusion.